Hello students, today's class we will study classification of amplifiers and the features of multi-stage amplifier, gain, bandwidth, calculations of multi-stage amplifier, need of multi-stage amplifier. In the previous topics, in the first chapter we have studied the small signal transistor amplifier circuit analysis using H parameters. This is the first topic in the second chapter, multi-stage and feedback amplifiers. We start with the classification of amplifiers. So by the completion of this period, you will be able to know the classification of amplifiers on the basis of frequency, function, and the type of load, the period of conduction, and number of stages. Amplifiers are classified on the basis of frequency, depends on frequency. Amplifiers are classified low frequency, high frequency, mid frequency amplifiers, RF and audio frequency amplifiers and radio frequency amplifiers. Like functions, based on the function, based on the type of load, the period of conduction, and also the number of stages, amplifiers are classified. So the small introduction of small signal amplifiers. Functions in the collector current are small compared to its quiescent value. Fluctuations, that swing in the collector current, variations in the collector current or collector to emitter voltage are very small compared to its quiescent value. Small signal amplifiers are also known as voltage amplifiers, and these are used in the first stage of the amplifier circuits, in the radio, television receivers, tape recorders, stereos, and also in measuring instruments. We'll use these small signal amplifiers as a first stage, where it's going to amplify the voltage signal. So that what this we have studied in the first chapter, small signal amplifiers and the analysis using H parameters in the three different configurations of transistor, C, CB and CC amplifiers with using H parameters. So the classification, coming to the classification, amplifiers are classified based on the frequency. DC, direct coupled amplifiers, 0 to 10 Hz frequency is we considered as 0, very low, and this will going to amplify the DC signals or slow varying currents or voltages. For amplifying, we will use these DC amplifiers and their frequency range is only 0 to 10 Hz. Audio frequency amplifiers, AF, that is audio frequency range 20 Hz to 20 kHz, and this will amplify the audio frequency signals used in the sound systems. And IF amplifiers, intermediate frequency amplifiers, amplifies the single frequency known as IF frequency. And radio frequency amplifiers, high frequency amplifiers known as high frequency amplifiers above 20 kHz, amplifies the frequencies of signals above 20 kHz, usually much higher, and this will be used in the communication systems, transmitters. And video amplifiers, 0 to few megahertz range, will amplify this. These amplifiers video amplifiers amplifies the signals over the wide band of frequencies in the order of megahertz, especially used in the televisions to amplify the video signals. So the amplifiers based on the frequency, they are classified into low frequency, direct DC amplifiers, direct current, that is direct current. Direct current means 0 to frequencies from 0 to 10 has almost 0 frequencies, low frequencies, and low frequency amplifiers, audio frequency amplifiers in the range of audio frequency 20 Hz to 20 kHz, and the interval frequency amplifiers, IF amplifiers, and RF frequency, radio frequency or high frequency amplifiers, and video frequency amplifiers in the range of megahertz. Based on the function, amplifiers are classified as voltage amplifiers and power amplifiers. Based on the signal, the amplifier is amplifying. Whether it is amplifying the voltage signal, it is voltage amplifier, and if it is amplifies the current, then it is current power amplifier. Otherwise, voltage amplifiers increases the voltage level of the input signal and used in the initial stages of multi-stage amplifier. Voltage amplifiers are used as initial stages in the multi-stage amplifiers. They are going to amplify the voltage level of the input signal. And power amplifiers increases the power level of the input signal. They are increases the power level of the input signal and used as final stages. Generally, as a final stages in the multi-stage amplifier, we will use these power amplifiers. So the voltage amplifiers are used in the for amplifying the voltage levels of the signal, and usually used in the input stages of multi-stage amplifier. And power amplifiers amplifies the power level of the signal and usually used in the output stages of the multi-stage amplifier. Based on the function, these are the two classification: voltage amplifier and power amplifier. Based on the magnitude of the input signal, so if the signal to be amplified, the amplified signal to be amplified, or that is the input signal. Based on its magnitude, amplifiers are classified into small signal amplifiers and large signal amplifiers. So small signal amplifiers generally the output signal peak to peak swing in collector current is less than 10% of the quiescent collector current, that is the operating DC collector current. So the small signal amplifiers are amplifiers where the peak to peak, maximum to maximum, negative peak to positive peak variation swing in the collector current is only less than 10% of the DC collector current. So these are examples of small signal amplifiers or voltage amplifiers. Large signal amplifiers where the peak to peak signal changes almost all of the load line. So the peak to peak signal variation is almost covers the full load line. So therefore they are used as a final stage amplifier, final stage in the multi-stage amplifiers. Large signal amplifiers examples are power amplifiers. So based on the peak to peak variation of the output signal, the peak to peak variation of the amplified signal is very small, then it is a voltage amplifier. The peak to peak variation of the amplified output signal is very large, and it is called as a large signal amplifiers or power amplifiers. Based on the type of load, amplifiers are classified as untuned amplifiers and tuned amplifiers. Untuned amplifiers based on the type of load. A resistor is used as the load in the collector circuit. In the untuned amplifiers, resistor is used as a load in the output circuit, collector circuit. So generally known as wideband amplifiers or untuned amplifiers. Examples of wideband amplifiers are audio frequency amplifiers and video frequency amplifiers. Video amplifiers, audio AF amplifiers and video amplifiers are comes under wideband amplifiers, where there is no fine tuning is not there, because we are using a resistor. It is not a tuning element, so not depends on the frequency, so it is known as untuned. If the collector current uses only resistor as a load, in the collector current if only a resistive load in the collector circuit of the amplifier, then it is called as untuned amplifier, or also known as wideband amplifier. Examples are AF amplifier and video amplifiers. Tuned amplifiers, based on the type of load, amplifiers are classified into untuned amplifiers and tuned amplifiers. Tuned amplifiers circuits used in the tuned circuit is used in the collector circuit. So in the tuned amplifiers, tuned circuit, LC circuit, some C or L elements, inductor or capacitor used in the collector circuit, and these are narrowband amplifiers. Tuned amplifiers are narrowband amplifiers. Examples of narrowband amplifiers are IF amplifiers and RF amplifiers used in the television and used in the radio FM receivers, RF and IF amplifiers. And tuned amplifiers further classified. Tuned amplifiers uses the tuned circuit in the collector, and because of this the frequency response is narrow, and hence they are known as narrowband amplifiers. Examples of narrowband amplifiers are IF amplifiers and RF amplifiers. And coming to again the tuned amplifiers further classified into a single tuned amplifier and a double tuned amplifier. See, in the collector circuit, if only one tuned circuit is used, LC circuit, tuned circuit is LC circuit, then it is called a single tuned amplifier. Here we are using a one tuned circuit. This is the one tuned circuit used in the collector of the collector circuit of the amplifier. It is called a single tune. It is called a single tune amplifier. If the collector circuit of the amplifier uses more than one, this is one, another one, and this is second tune. Two, the collector of the amplifier circuit uses more than one, so it is called double two tuned circuits in the collector of the amplifier circuit. Then it is called as double tuned amplifier. So based on the load in the output circuit or the collector circuit, the amplifiers are classified into untuned amplifiers and tuned amplifiers. If untuned amplifiers uses the resistor in the collector circuit, examples are wideband amplifiers, and tuned amplifiers uses the tuned circuit in the collector. That examples are IF and RF amplifiers. Tuned circuit is LC circuit, and again the tuned amplifiers are further classified into single tune and double tune amplifiers. Based on Again, coming to the classification, the amplifiers are classified based on the period of conduction. So based on the period of conduction, amplifiers are classified into how much time the transistor is conducting during the amplification. That period, considering that period, the amplifiers are classified into class A amplifier, class B amplifier, class C amplifier, and class AB amplifier. Class based on the period of conduction, the amplifiers are classified into class A amplifier, class B amplifier, class C amplifier, and class AB amplifier. So the position of the Q point and the portion of the characteristics that is used to determine the method of operation. See, based on the position of the operating point on the load line, the transistor is going to conduct a part or a full cycle of the input signal. Amplifier circuit is transistor is going during the amplification. The amplifier circuit is used to conduct full cycle or a part of the cycle of the input signal. The output current flows. Then accordingly, the amplifiers are classified into class A, class B, class C, and class AB amplifiers. So the period of conduction is depending on the location of the operating point on the load line. So in the class A amplifier, the operating point Q point is located in the middle of the load line. So we'll get the output current flows for full cycle of the input signal. So the operating point is located, since the operating point is located in the middle, so in the class A amplifiers, the output current flows for full cycle of the input signal. Conduction angle is 360 degrees. Conduction angle is 360 degrees. Theta is 360 degrees. In class A amplifier, the operating point Q point is located in the middle of the DC load line, so the output current flows for full cycle of the input signal, that is the conduction angle is 360 degrees. In class B amplifier, the collector current, the Q point is located on the cutoff point on the load line, at the cutoff point on the load line, that is on the x-axis, cutoff point on the load line. So the collector current flows only half cycle of the input signal, only 180 degrees, only half cycle of the input signal, since because the operating point is located on the cutoff, at the cutoff point on the load line. So at the Q point is located at the cutoff point on the load line, so therefore the output current, collector current flows only half cycle of the input signal. So therefore we have only half cycle for full cycle of the input signal. So therefore conduction angle is theta is 180 degrees. Theta is 180 degrees. Class C amplifiers. In class C amplifiers, class A conduction angle is 360 degrees, class B the conduction angle is 180 degrees based on the location of the operating point. In the class C amplifiers, the operating point located below the cutoff point on the DC load line. Therefore collector current flows less than half cycle of the input signal, and the collector current is in the form of pulses, and conduction angle is less than 180 degrees. In the class C amplifiers, the conduction angle, the operating point is located below the cutoff point on the load line, so therefore the output current flows less than half cycle of the input signal, and the collector current looks like in the form of pulses, and conduction angle here is less than 180 degrees. So here in the class C amplifiers, Q point is located. In class C amplifiers, Q point is located below cutoff. Therefore, the conduction angle, collector current flows theta is less than 180 degrees. 180 degrees, less than 180 degrees in the class C conduction angle, and the collector current in the form of pulses. In the class AB amplifier, the Q point, so in the class A conduction angle is 360, in class B conduction angle is 180, in class C conduction angle is less than 180. In class AB amplifier, Q point operating point is located between cutoff point and middle of the DC load line. So in between middle of the DC load line and cutoff point, the Q point is located. If the Q point is located, then the conduction angle. So if the Q point is located in the middle of the DC load line, the conduction angle is 360. If the Q point is located at the cutoff point on the DC load line, then the conduction angle is 180. If it is located in between, so the conduction angle is more than 180 and less than 360. So in class A, so it is the operation in between class A and class B. So the conduction angle falls between class A and class B. So it is class AB amplifier. So in class AB amplifier, theta is conduction angle is in between 180 to 360 degrees. Conduction angle is theta is 180 to in between 180 to 360 degrees. So this is class AB amplifier. Collector current flows more than half cycle but less than full cycle of the input signal. It operated between the two extremes of class A and class B, and this is known as class AB amplifier. So based on the period of conduction, amplifiers are classified into class A, class B. Class A, where the conduction angle is 360, class B conduction angle is 180, class C conduction angle is less than 180, class AB conduction angle is more than 180, less than 360. And coming another classification based on the number of stages, amplifiers are classified into single stage amplifiers and multi-stage amplifiers. Based on the number of stages, amplifiers are classified into two types: single stage amplifier and multi-stage amplifiers. Again, the multi-stage amplifiers are further classified into type of coupling because one output of one stage is connected to input of the next stage, then it is in that multi-stage amplifier. So the type of coupling, based on the type of coupling between the two stages, so in the multi-stage amplifier, the amplifiers are classified into based on the type of coupling. The multi-stage amplifiers are classified into RC coupled amplifier. If a resistor and capacitor is used for coupling the two in the multi-stage amplifier, then it is known as RC coupled amplifier. If the transformer is used for the coupling in the multi-stage amplifier, it is transformer coupled amplifier. If one stage is directly connected to the next stage in the multi-stage amplifier, then it is called as direct coupled amplifier, and the impedance is used for coupling the multi-stage amplifier, then it is impedance coupled amplifier. So based on the stages, number of stages, again the amplifiers are classified into single stage amplifiers, single stage amplifier, and multi-stage amplifier. Single stage amplifiers employs only one transistor with associated circuit, that is the biasing circuit, used for amplifying the signal, weak signal. The circuit is known as single stage transistor amplifier. Only one transistor is used, and along with the biasing circuit for amplifying the given input signal, it is known as a single stage amplifier. And the multi-stage amplifier, its circuit is containing more than one stage for in the amplification. The number of single stage amplifiers are connected in cascade arrangement. The circuit containing more than one stage in the amplification in the multi-stage amplifiers. So amplifier, the amplified signal of the first stage is connected as input to the second stage, and the amplified output of the second stage is connected as input of the third stage, and so on. So the output of the one stage is connected as input to the next stage in the multi-stage amplifier. In the multi-stage amplifier, circuit is containing more than one stage in the amplification. Number of single stage amplifiers are connected in cascade arrangement. So multi-stage amplifiers, based on the type of coupling, the multi-stage amplifiers are known as RC coupled amplifier. Capacitor is used as the coupling device in the multi-stage amplifier, then it is known as RC coupled amplifier. Transformer coupled amplifier, see, this is the resistance and capacitance are used in the coupling of a multi-stage amplifier, so it is known as RC coupled amplifier. And if the coupling between the two stages is employed by using the transformer, then it is known as transformer coupled amplifier. If the coupling is employed using an inductive circuit, inductive capacitor and resistor, then it is called as a impedance coupling.